Okay, so today we'll start expansion. We continue on power series. In our previous class, we learned about Maclaurin series and Taylor series. And we said that Maclaurin series, this means your point is 0. Taylor series, you'll have another point. And we stop at this example. We have sine x. We found the Maclaurin series of sine x and cos x. And a quick revision to find the Maclaurin series for sine x, for the function sine x. So we substitute x equal to 0 because we have a Maclaurin series. Maclaurin series means that your point is 0. So sine 0 is 0. Then you need to find the first derivative, cos x. The derivative for sine is cos. Then you have to calculate the first derivative at 0. So cos 0, which is equal to 1. Then you need to find the second derivative for the function, which means the derivative for cos x is minus sine x. The derivative for cos x is minus sine x, which means that the second derivative for 0 is 0. The third derivative for x is minus cos x, then the third derivative of 0 is minus 1. The fourth derivative for x is sine x, so you have 0 again. Then we apply Maclaurin series. Maclaurin series, which means FA, F0, which is 0, so the first term is 0. Then the first derivative at 0, which is 1, multiplied by x. Then the second derivative, which is 0, so no x squared. Third derivative is minus 1, so you have minus 1 multiplied by x cubed over 3 factorial. Fourth derivative is 0, so you don't have x to the power 4. The fifth derivative will be 1 again, so 1 multiplied by x to the power 5 over 5 factorial. And x to the power 6 will be cancelled because the 6th power will be 0 and the 7th power will be minus 1. So minus x to the power 7 over 7 factorial. This is the Maclaurin series of sine. By same way, you can find the Maclaurin series of cos x, or you can find the Maclaurin series by cos x by find the derivative for sine. The derivative for x is 1. The derivative for x cubed over 3 factorial is 3x squared over 3 factorial. The derivative for x to the power 5 is 5x to the power 4 over 5 factorial. The derivative for minus x to the power 7 over 7 factorial is 7x to the power 6 over 7 factorial. So you have, this is the power series of cos. So we can find cos x by find the derivative or sine, or you can go for similar step to find the Maclaurin series of cos x. This is all what we learned on our previous class. Also, we learned how to, if we already calculate cos x, how can we calculate cos 2x and cos 3x? We just remove x and replace it by 2x. To find cos 2x, just replace each x by 2x. Replace each x here by 2x to find the Maclaurin series of cos 2x. Same if you need to find cos 3x, you need to go for cos x and replace each x by 3x. Replace each x by 3x. Now to find sine square x. To find sine square x. Sine square x, you can find it using the identity. Instead of going to calculate the Maclaurin series from the beginning, you can use the identity because sine square x is equal to 1 over 2 1 minus cos 2x. This is the identity of sine square x. So 1 over 2, 1 minus cos 2x. So you have 1 over 2, 1 minus. Now cos 2x will be replaced by the series, the Maclaurin series cos 2x, this one. Cos 2x, 1 minus 2x squared, I will write it here. 1 minus 2x squared plus 2 over 3x to the power 4. This one here is the Maclaurin series of cos 2x. Maclaurin series of cos 2x. Here should be have another bracket. I think this one. cos 2x. This is the Maclaurin series of cos 2x. So 1 over 2, 1 minus cos 2x. So it becomes 1 over 2. 1 with minus 1 will be cancelled. So you have minus 2x squared, which is 2x squared, minus plus 2 over 3x to the power 4 is minus 2 over 3x to the power 4. Minus is plus 2 to the power 6, x to the power 6 over 6 factorial. So this will become, so now divide by 2, you will have the Maclaurin series of sine square x. We find it by using cos x or cos 2x. No need to go and evaluate from the beginning. Similar for cos cube x. You can use identities because cos cube x is equal to cos square x cos x. Cos square x cos x, and cos square is 1 minus sine square. Since we already calculate sine square, this one, so replace sine square by its Maclaurin series and multiply by cos x. Multiply by the Maclaurin series of cos x. So 1 minus sine square is 1 minus x squared plus 1 over 3x to the power 4 minus 2 to the power 5 x to the power 6 over 6 factorial. This is 1 minus sine square. This is 1 minus sine square multiplied by Maclaurin series of cos x. So you need to multiply all the terms. First, we multiply 1 by the fourth terms here. So we have 1 minus x squared over 2 factorial plus x to the power 4 over 4 factorial minus x to the power 6 over 6 factorial. Then we multiply x squared. We have minus x squared times minus x squared over 2 factorial is x to the power 4 over 2 factorial. Then I multiplied minus x squared multiplied by x to the power 4 over 4 factorial, which is minus x to the power 6 over 4 factorial. Then we multiplied 1 over 3x to the power 4 by 1, which is 1 over 3x to the power 4. And 1 over 3x to the power 4 multiplied by minus x squared over 2 factorial. So it's minus x to the power 6 over 6. And finally, we multiply this one by 1 only. So the highest power I need is 6 because it is enough for me to get 4 terms. No need to go for x to the power 8 and so on. The first 4 powers, because you don't have odd power here, so the first 4 terms will include the constant x squared, x to the power 4, and you have include another term including x to the power 6, including x to the power 6. So this is what a quick revision of the last example that we did in our previous class. This one. So now we need to, so this one we just calculate from identities. We have sine square. We use this identity 1 over 2, 1 minus cos 2x. And cos cube x, we make it cos square x cos x. Now we need to find Taylor series because all the previous example we found Maclaurin series, which means our point was 0. Now our point is x equal 1. Our point is x equal 1. So we have f of x. This is the function. F of x is equal 3x squared minus 6x plus 5. And your point is x equal 1. So you need to find the values at 1, not at 0. You need to find the values at 1, not at 0. So f1 here, substitute x equal to 1. Substitute x equal to 1. So you have 3 minus 6. Minus 6 plus 5, which means that you have 2. Substitute x equal to 1. Substitute x equal to 1. So 3, if you put x equal to 1, 3 minus 6 plus 5, you have f1 is equal to f1 is equal to. Now calculate the first derivative. Same step like Maclaurin series. The only difference that instead of 0, we calculate at x equal to 1. So the first derivative will be 6x minus 6. 6x minus 6, which means that the first derivative at 1, substitute x equal to 1, which is 0. Which is 0, because 6 minus 6 is 0. Now the second derivative of x, which is 6. The second derivative for 1 is equal to 6. Is equal to 6. Now if I evaluate the third derivative, of x, because the second derivative is 6, which is constant, so the third derivative will be 0. So the third derivative at 1 is 0. So we have to stop here because all the derivative after that will be 0. Now we need to apply Taylor series. Taylor series, this one. Not Maclaurin, Taylor one, this one. Because this is the formula of Taylor series. This is the formula of Maclaurin series. When have a point equal to 0. But another point, you have to apply this formula, this one. So to apply this one, f of x will be equal to fa plus x minus a, first derivative of a, plus x minus a squared, 2 factorial second derivative for a plus x minus a cube, over 3 factorial third derivative for a. Third derivative for a. So which means that equal to, I will write it here, f of x equal to fa plus x minus a, the first derivative of a, plus x minus a squared, second derivative for a, over 2 factorial. Over 2 factorial. Now f of a, f1, a is 1, is equal to, f of a is equal to plus. Now the first derivative is 0. The first derivative here is equal to 0. At 1 is equal to 0. So f, because, okay, now maybe to not confuse, a here is equal to 1. Our point here is 1. Our point here is 1. Our point here should be equal to 1. So now the first derivative at 1 is 0, which means this term should be cancelled. This term should be cancelled. Now the second derivative of 1 is equal to 6. The second derivative is equal to 6. So we have 6 over 2 factorial x minus 1 square. X minus 1 square, which means 2 over 3 plus 6 over 2 factorial, which is 3x minus 1 square, and this is the Taylor series of the function 3x squared minus 6x plus 5 around the point x equal to 1. Around the point is x equal to 1. If x equals 0, then it becomes Maclaurin series. If x equal 2, then you need to replace 1 by 2. You need to substitute. You need to calculate the function and its derivative, second derivative normally. But the point here, you substitute the point x equal 2 instead of x equal 1. Instead of x equal 1. Here we need to find the Maclaurin series for the first 4 terms. First 4 terms of ex and 5 terms of sine x. Hence, deduct that Maclaurin series for Ex sine x is given by this one. We already found the Maclaurin series of Ex and sine x before. We already found the Maclaurin series of Ex and sine x before. For Ex, this one, in our previous class, we already found the Maclaurin series of Ex. This one. 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. So this is the Maclaurin series of Ex. Maclaurin series of Ex. So here Maclaurin series of Ex is 1 plus x. In this example, you have to find it completely, but I will not. I will write it directly because we already solved it before. But on the exam, you have to write the step how we calculate the Maclaurin series of Ex. There's a question here. How many terms must we write for the answer? At least 4 terms. At least 4 terms you need to write. Okay, so one Maclaurin series, I will not calculate it again because we calculate it in our previous class. So Maclaurin series is equal 1 over x, 1 over 2 factorial x squared, 1 over 3 factorial x cubed. This is the Maclaurin series of Ex. Now, the Maclaurin series of sine x also we calculate it here. This is how we calculate the Maclaurin series of sine x. This is how we calculate the Maclaurin series of sine x. So this is the Maclaurin series of sine x. So I will write it down here. But if you have like this question in the exam, you need to write the full steps, how to find. Okay, sine x is equal to x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial minus x to the power 7 over 7 factorial. And then you need to find, we need 5 terms of sine x. 1, 2, 3, 4. We need another term here. So x to the should be x to the power 9 over 9 factorial. Okay. Now we need to find Ex. We need to find Ex multiplied by sine x. Hence, deduct that Maclaurin series of Ex sine x is given by this one. Ex sine x. We need to find Ex sine x. So you need to multiply. You need to multiply Ex by sine x. First, started from 1. If I multiply 1 by, I think enough 4 terms. No need to go for x to the power 9. Here is stop at x to the power 5. So I will stop at x to the power 5 as well. So here 1. So you have x minus x cubed over 3 factorial. Now I'm do the multiplication. 1 times x. 1 times minus x cubed over 3 factorial. 1 times x to the power 5 over 5 factorial. I'm starting the multiplication from the 1 here. So you have x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial. Now I will go to do the multiplication of x. Since I multiply 1, I will multiply x. So I will multiply x by x. We have x squared, x minus x cubed over 3 factorial, x times x to the power 5 over 5 factorial. So x times x is x squared and x times minus x cubed over 3 factorial is x to the power 5 over 3 factorial. X times minus x cubed over 3 factorial is, x to the power 4. This one should be x to the power 4. X to the power 4. X to the power 4. Because here I multiplied x by x, we have x squared. X times minus x cubed over 3 factorial is minus x to the power 4 over 3 factorial. Now, x times x to the power 5, we have x to the power 6, but we need to stop x to the power 5 because we need only the first 4 terms. So we have x squared, x to the power 3, and x to the power 4 is x to the power 5, so it's enough. No need to go for x to the power 6. So now I need to multiply this term. This term, 1 over 2 factorial, x squared times x. So we need plus 1 over 2 factorial x cubed. One over 2 factorial x squared times x is 1 over 2 factorial x cubed. Now 1 over 2 factorial x squared multiplied by minus x cubed 3 factorial is equal to minus 1 over 2 factorial 3 factorial multiplied by x to the power 5 multiplied by x to the power 5. X squared x cubed is x to the power 5. 1 over 2 factorial multiplied by 1 over 3 factorials. Now x squared times x to the power 5 will give you x to the power 7, so no need. And finally, we can multiply 1 over 3 factorial x cubed by x. So you have 1 over 3 factorial x to the power 4. So now we can evaluate. The first term is x. You can just the first term is x. The second term should including x squared. We have one term x squared, so you have x plus x squared. X plus x squared. Now x cubed. We have two terms including x cubed. 1 minus 3 factorial and plus 1 over 2 factorials, which I think should be 1 over 3. 1 over 3. 1 over 3 x cubed. And calculate x to the power 4, x to the power 4. X to the power 4, you have two terms you need to add. X to the power 4 will be cancelled because minus 1 over 3 factorial plus 1 over 3 factorial will cancel each other. So x to the power 4 will be cancelled. So you have x to the power 5. So you have only x to the power 5. You need to evaluate. Okay. Now in this example, you need to use Taylor theorem to obtain series expansion of the first 5 derivative for cos x plus pi over 3. And by using this one, we need to find cos 62. We need to find cos 62. Since you have x plus pi over 3, which means this is a Taylor series. This is a Taylor series. This is not a Maclaurin series. So we need to use this formula, this one. Because this is the formula of x plus a. This is the formula of x plus a. You can use fx plus a, this one. Or you can use f of x, but then your a is pi over 3. We can use this one, f of x. Fx plus a is equal, a here is pi over 3. Fx plus a is equal to fa plus x, the first derivative for a, x squared over 2 factorial, the second derivative for a, this one. We can use this one. A here is pi over 3. A here is over 3. So I will use the formula. I will write the formula here. F of x, fx plus a equal to fa plus x f prime a plus x squared over 2 factorial, second derivative for a, and so on. But here we need up to 5 terms because the questions ask you to find the first 5 derivatives. So you need to calculate the derivative until you reach the 5th derivatives, until you reach the 5th derivative. So your point is, or your function is, cos fx plus a is equal to cos x plus pi over 3 plus pi over 3. So the function is cos x. Our function is cos x. So we have f of x is equal to cos x. Then we need to find f pi over 3, which is equal to f pi over 3 is equal to 1 cos pi over 3, which is equal to 1 over 2. Then the first derivative for cos is minus sine x. Minus sine x. Then the first derivative at the point pi over 3 is equal, the first derivative at pi over 3 is equal to minus square root of 3 over 2. Now the second derivative for x equal to minus cos x. Then the second derivative at pi over 3 is equal to minus 1 over 2. The third derivative for x is equal to sine x. Then the third derivative at pi over 3 is equal square root of 3 over 2. Square root of 3 over 2. And then the fourth derivative for x, the derivative for sine is cos x. The derivative for the derivative for sine is cos x. Then the fourth derivative for pi over 3 is equal to cos pi over 3, which is mean 1 over 2. Also the fifth derivative, because we need to find until fifth derivative. So cos x derivative is minus sine x, which means that the fifth derivative at pi over 3 is equal to 1 over 2. Is equal to minus square root of 3 over 2. Over 2. Here we will stop under fifth derivative because we need to use the first 5 derivative for cos x plus pi over 3. Now we need to use the formula. You can use one of the previous formula. You can choose one. you can choose one of these formula, this one or this one. We can follow the first one as usual or the second one. Okay, following the first one, f of x or cos x, f of x, following the first one, f of x is equal to fa plus x minus pi over 3 f prime of a, so plus second derivative for a x minus pi over 3 square over 2 factorial. Okay, plus f triple a x minus pi over 3 cube over 2 factorial plus f4 of a over 4 factorial x minus pi over 3 to the power 4, and then plus f fifth of a x minus pi over 3 to the power 5 over 5 factorial, So now we need to substitute. F of x is cos x, f of a is 1 over 2 minus the first derivative for a is square root of 3 minus square root of 3 over 2 multiplied by x minus pi over 3 minus the second derivative is 1 over 2 multiplied by x minus pi over 3 square divided by 2 factorial plus square root of 3 over 2 x minus pi over 3 cube over 3 factorial, and the fourth derivative is the fourth derivative for x, fourth derivative for pi over 3 is 1 over 2, so plus 1 over 2 x minus pi over 3 to the power 4 over 4 factorial, and the fifth derivative is equal to minus 3 minus square root of 3 over 2 x minus pi over 3 to the power 5 over 5 factorial. Now to find cos 62, we find cos x, we need to find cos 62. To find cos 62, you need to substitute x by 62. So cos 62 degree, which equal to cos 62 degree and I think 31 over 90 pi. 31 over 90 pi. So you need to substitute x. By 31 over 90 pi. So here we will substitute x by 31 over 90 pi. So you will have this result. If you calculate, which is equal 2.5, the first one, minus 0.03, 0299, minus 0.00034 plus 0.006. So, which is equal to 0.469 degree. If you need to apply the formula f of x, here we apply the formula f of x. To apply the formula f of x cos x plus a, then you need to substitute x here. So your x will be not 62, will be equal to 2. If you will apply the second formula, then the x will be equal to not 62 degree. If you will apply this one, if you apply this one, f of x plus a is equal, then instead of x minus pi over 3, you have x. And here, x will not equal to 62, equal 2 only, because 2 plus pi over 3, okay, or pi over 90 plus pi over 3 will be 62 degree. 62. If this one will make you confused, you can keep using the first one. Keep using the first one. Then you can keep on. Okay, so our next example, if y equal to ln cos x. Okay, this example, if y is equal to ln cos x, show that the second derivative plus 1 plus dy over dx square equal to 0. This one is normal one, as we did on chapter 2. You need to find the first derivative. You have y equal, we need to prove this one first. We have ln cos x. Y is equal to ln cos x. So you need to prove this one. Dy over dx is 1 over cos x multiplied by the derivative for cos, which is minus sine x. Minus sine x, so this one minus tan x. Minus tan x. Now find the second derivative. Dy over dx square. The second derivative minus tan x minus sec, the derivative for tan is sec x tan x. Minus sec x tan x. So 1 plus, so you need to prove this equal to 0. Now I will substitute on left hand and it will equal to the, I will substitute on right hand and I will prove it is equal to 0. So minus, you have, wait. D square y over dx square plus 1, I think. Plus 1 plus dy over dx square. Plus dy over dx square. Now the second derivative here is minus sec x tan x. Minus sec x tan x plus 1 plus dy over dx square, which is equal to dy over dx tan square plus tan square x plus tan square x. So, sorry مشتق okay sorry. I think here the derivative for tan is sec square. Sorry, this one is incorrect. The derivative for tan is sec square, so you have minus sec square here. The derivative for sec is sec tan. So the derivative for tan is sec square. So minus tan x, so minus sec square. So we have minus sec square. This one also we need to correct. Minus sec square plus 1 plus tan square. Plus 1 plus tan square. Plus 1 plus tan square x, which is equal, because 1 plus tan square is sec square, with minus sec square is equal to 0. 1 plus tan square is sec square, with minus sec square equal to 0. So these are equal. Now the question is, what we need to use this relation to find the Maclaurin series for y ln cos x until we have the term x to the power 4. We need to use this to have the Maclaurin series of this function until the term x to the power 4. Maclaurin series, your point is 0. Maclaurin series, your point is 0. Okay, to find the Maclaurin series, I need to find the function at 0. I need to find first the function at 0. So for Maclaurin series, my function is ln cos x. F of x is ln cos x. So f0, cos 0 is 1, ln 1 is 0. Now the first derivative is minus tan x. So the first derivative at 0, so tan 0 is equal to 0. Tan 0 is equal to 0. Now the second derivative for x is minus sec square x. Is minus sec square x, or we need to use the relation series. We need to use this relation. From here, the second derivative from this one. The second derivative will be minus 1 minus dy over dx squared. It's equal to minus 1 minus f of x squared, which is minus 1 minus tan square x. Now, the second derivative at 0 will be minus 1. Will be minus 1 because the first derivative is 0. Now, the third derivative, since I have minus 1, then I have minus x squared. The third derivative would mean I need to find the derivative for this relation here. I need to find the derivative for minus 1 minus the first derivative square. So the derivative for minus 1 is 0. So it is equal to minus 2 minus 2. First derivative at x, second derivative of x. Second derivative for x. Now if you substitute 0 because the first derivative at 0 is equal to 0. So the third derivative should be 0 as well. Now using the same relation, I need to find the fourth derivative. Here I have a multiplication of two functions. So I need to use the product rule. So using the product rule, so you have minus 2. The first function I will keep same. So the second one, it will be the third derivative of x plus minus 2 second derivative of x squared by using the product rule. Now calculate the fourth derivative at 0. Calculate the fourth derivative at 0. This term will be cancelled because the first derivative at 0 is 0. So this term will be cancelled. So you have minus 2. The second derivative at 0 square, which is minus 2. The second derivative is minus 1. Minus 1 square. So minus 1 square. So you have minus 2. So we stop here because he asked me to stop at x to the power 4. X to the power 4 means that the fourth derivative, because the fourth derivative will multiply by x to the power 4. So you don't have the first term or the second term. You have only x squared and x to the power 4. So your Maclaurin series here up to x to the power 4 is equal to f of x, or the function here is f. The second derivative is minus 1, so minus x squared over 2 factorial minus 2x to the power 4 over 4 factorial. If you have any question, please write on the chat or you can open the mic. So I just used this relation. I proved this relation first, that the second derivative plus 1 plus dy over dx squared equal to 0. Then after I use this one, after I prove, this one, I use it to find the Maclaurin series. Because this is the first, this is the function, this is the first derivative. Maclaurins means your point is 0. Find the function at 0. Find the first derivative at 0. Now, for second derivative, I will use this relation, this one. Second derivative is minus 1 minus dy over dx squared. Minus 1 minus dy over dx would mean the first derivative squared. The first derivative is minus tan x, so 1 minus tan squared x. Or the first derivative of 0 is 0. This one is cancelled. So you have the second derivative is minus 1. The second derivative is minus 1. Now to calculate the third derivative, you need to find the derivative for this relation. The derivative of minus 1 is 0. So now we have a power function minus 2. The first derivative of x multiplied by the second derivative for x. At 0, you need to find the third derivative. At 0 should be 0 because the first derivative at 0 is 0. To find the fourth derivative, here we have a multiplication of two functions. By using the product rule, you have minus 2 f prime x multiplied by the derivative, the second derivative of x, which is the third derivative. Now I need to fix this one, minus 2. I need to find the derivative for this one, minus 2. The derivative for f prime x or f dash x is equal to the second derivative for x multiplied by second derivative of x, which means second derivative squared. At 0, you have minus 2. At 0, you have minus 2. So this is the Maclaurin series up to the term x to the power 4. X to the power 4.
Doctor,
Now, yes.
I have a question.
Yes.
For the first, for the third derivative, right?
First
Is
derivative?
the third one.
Yes.
We will get negative 2 and then times tangent x times secant square x instead
My,
of negative 2 negative tangent x.
you need to calculate this one. Minus 2 times this one. Because he need you to use the relation. Okay, so use the relation because I can. Okay, you need to follow the instruction. Actually, I don't. If I need to solve this question, no need to go for this relation. You can just here directly calculate the derivative for minus tangent x, which is minus sec square. You can do this directly. But since the question asks you to use this relation by differentiating the above expression several times, so you need to differentiate the expression itself. Okay, I know that you can do that. That you need to, for third one, you just find the derivative for minus 1 minus tan squared x. You can, but we have to follow the instruction of the question. Instruction asks you to differentiate the relation. So you need to differentiate this one, not to, oh, actually I no need to evaluate this one because the second derivative can be calculated directly from here. So I need to differentiate this expression several times to follow the instruction of the questions. If this last instruction not here, no need to do for this. You just go for normal steps to find the Maclaurin series. Just learn cos x minus tan x, second derivative minus sec square x. Third derivative, you need to evaluate the derivative for minus secant square x, and so on. But here, I will not do that because the question asks you to integrate or to differentiate, this expression several times. So you need to follow the instruction. That's why I didn't find the derivative for minus 1 minus tan squared directly. So here just to follow the instruction. But if you to check your answer, okay, you can do the another step just to check your answer that you have same answer. Finally, the final answer should be same for both. Okay, now for how to find the limits with Taylor series and Maclaurin series. How to find the limits for Taylor series and Maclaurin series by using. You can direct substitution to find the limit. If you do direct substitution, you have e to the power 0 is 1. 1 minus 1 is 0 over 0, so you have 0 over 0. So usually we go for L'Hopital rule, but here we will use Maclaurin series. I will use Maclaurin series to find the limit. First, we need to find Maclaurin series for Ex. Maclaurin series for Ex. Do you remember Maclaurin series for Ex? Maclaurin series for Ex is 1 plus x plus x squared over 2 factorial plus x3 of x to the power 3 over 3 factorial, and so on. This is the Maclaurin series. Here he didn't give you how many terms, so it is enough at x maximum, x to the power 4. X to the power 3, x to the power 4 is enough. No need to go more. So this is Ex. Now I need to find the limit when x goes to 0 for Ex minus 1 minus x over x squared. So we need to calculate this term first. Ex minus 1 minus x from here. Ex minus 1 minus x will be equal to x squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial. Now dividing by x squared, so Ex minus 1 minus x dividing by x squared which means 1 over, I need to divide by x squared. So 1 over 2 factorial plus x over 3 factorial plus x squared over 4 factorial. So now I need to find the limit when x goes to 0. Limit when x goes to 0 for ex minus 1 minus x over x factorial. It should be equal to the limit when x goes to 0 for this term, for this one. 1 over 2 factorial, 1 over 2 factorial plus x over 3 factorial plus x squared over 4 factorial. So substitute x equal to 0. So this term goes to 0, this term goes to 0. So the limit is equal to 1 over 2 factorial, which is 1 over 2. 1 over 2. So the limit 1 over 2. I started from the Maclaurin series of Ex. This is the Maclaurin series of Ex. Then from Maclaurin series of Ex minus 1 minus x. So these two terms I transfer to the right side here. So Ex minus 1 minus x equal to x squared over 2 factorial, x cubed over 3 factorial, x to the power 4 over 4 factorial. Then we have over x squared. We need to divide both sides by x squared. So you have 1 over 2 factorial. This one too. X over 3 factorial. X to the power 4. So x squared over 4 factorial divided by x squared. So I need to find the limit when x goes to 0. Then just find the limit for this term. So all the terms have x will goes to 0. Only the first term, which is 1 over 2. Which is 1 over 2. By the same way, I need to find the limit for x squared plus 2x minus 2. X squared plus 2 cos x minus 2 over 3x to the power 4. I will start from the Maclaurin series of cos x. I will start from the Maclaurin series of cos x. Maclaurin series of cos x is equal to 1 minus x squared over 2 factorial plus x to the power 4 over 4 factorial. If I'm not mistaken, let me check about Maclaurin series of cos x. This one. Maclaurin series of cos x. This one. 1 minus x squared over 2 factorial plus x to the power 4 over 4 factorial plus minus x to the power 6 over 6 factorial. So what we write is correct. We go back here. One over, so we can add another term, minus x to the power 6 over 6 factorial. You can stop here. Now we need to calculate 2 cos x, because we have 2 cos x here. We have 2 cos x. So 2 cos x you need to multiply by 2. You need to multiply by 2. So you have 2 cos x is equal to minus x squared plus x to the power 4 over 12 minus x to the power 6, 2 over 6 factorial. Sorry. Over 6 factorial. Now again we have x squared plus 2 cos x minus 2. So I need to move the first two term here. So you have 2 cos x plus 2 plus x squared minus 2. Sorry. Equal x to the power 4 over 12 minus 2x to the power 6 over 6 factorial. Okay, now we have 2 cos x minus 2 plus x squared divided by 3x to the power 4. So you need to divide both sides by 3 to the... So you have 2 cos x squared plus 2 cos x minus 2 over 3x to the power 4 equal to... I need to divide by 3x to the power 4. So you have x to the power 4 divided by 3x to the power 4. You have x to the power 4 divided by 3x to the power 4 times 12. So this will be cancelled. So you have only 1 over 36. 36. Now divide this one by 3x to the power 4. So you have minus 2x squared 36 factorial. 36 factorial. And then take the limit when x goes to 0. Take the limit when x goes to 0 is for 1 over 36 minus 2x squared over 3 times 6 factorial. So which is equal to 1 over 36. 1 over 36. So here, similar step. I started from Maclaurin series for cos x. This is the Maclaurin series of cos x. I need 2 cos x minus 2 plus x squared. So I multiplied by 2 first. Then to get minus 2 plus x squared, just move to the right side, from left side to the right side. So you have 2 cos x minus 2 plus x squared equal to the remaining terms. Now divide both sides by 3x to the power 4. So you have, when divided by 3x to the power 4, x to the power 4 will be cancelled. So you have 3 times 12, 36. Here x over 6 when divided by x to the power 4, so x squared minus 2 over 6 factorial multiplied by 3. So when you take limit x goes to 0, this term will go to 0. So you have only 1 over 36. This is the limit. This is the limit. Can we use Maclaurin series to find the integral? Also, yes. You can use it to find the integral. Actually, if you try to integrate e minus x squared, you cannot integrate this function. Usually, you cannot integrate this function. So we will use Maclaurin series to approximate the value. We need to use only the first 6 terms. The first 6 terms. Let us write the Maclaurin series for e minus x squared. First, I will write the Maclaurin series for ex. Maclaurin series of ex, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial plus x to the power 5 over 5 factorial. Now we have 6 terms. 1, 2, 3, 4, 5, 6. 6 terms. Now I need from ex, I need to evaluate ex squared. E minus x squared. E minus x squared. So I will replace each x by minus x squared. I will replace each x by minus x squared. A cube over 3 factor. Replace each x by minus x squared. Or plus minus x squared to the power 5 over 5 factor. So replace each x by minus x squared. Be careful about the negative signs. So this one will be minus 1 minus x squared. Now the minus with square will go, so you have plus x to the power 4 over 2 factorial minus x to the power 3 over 3 factorial, sorry, minus x to the power 6. This one minus with odd power will keep minus, so x squared to the power 6 plus x to the power 8 over 4 factorial minus x to the power 10 over 5 factorial. Now we need to integrate from 0 to 1. We need to integrate this value from 0 to 1. From 0 to 1. So the integration here from 0 to 1, e minus x squared dx is equal to the integration of, I will integrate this Maclaurin series from 0 to 1, minus 1 minus x squared plus x to the power 4 over 2 factorial minus x to the power 6 over 3 factorial plus x to the power 8 over 4 factorial minus x to the power 10 minus x to the power 10 over 5 factorial dx. So you need to integrate and substitute from 0 to 1. The integration of minus 1 is minus x. The integration of minus x squared is minus x cubed over 3. The integration of x to the power 4 over 2 is x to the power 5 over 10. 5 times 2, which is 10. The integration of x to the power 6 over 3 factorial is x to the power 7. 3 factorials times 7. The integration of x to the power 8 is x to the power 9 over 9 times 8 factorial. Sorry, over 4 factorial. 4 factorial. And the integration of x to the power 10 is x to the power 11 over 11 5 factorial over 11 5 factorial. So all this one from 0 to 1. From 0 to 1. So you need to substitute this term by x equals 0 first, and then goes and evaluate when x equal 1 first minus x equals 0, all terms is 0. So we need to just substitute x equal to 1. So this is equal to, I will substitute 1 first. So you have minus 1 minus 1 over 3 plus 1 over 10. I'm substituting x equal to 1. I'm substituting x equal to 1. So minus 1 over 3 factorials times 7 plus 1 over 9 times 4 factorial minus 1 over 11 times 5 factorial. This is when x equal 1. Minus 0, because when x equal to 0, all terms are 0. When x equal to 0, all terms are 0. So you need to evaluate this one by calculator to find, I think, until 4 decimal places. They didn't mention, so 4 or 3 decimal places is okay. So you need to evaluate this one using the calculator. To evaluate. So instead of, in case some function that we don't know how to integrate, we can approximate the value by using Maclaurin series. We write the Maclaurin series for e minus x squared, and then we integrate, we find if the Maclaurin series of ex. From this one, we find the Maclaurin series of e minus x squared by replacing each x by minus x squared. So this is the Maclaurin series of e minus x squared. Integrate the series. Instead of integrating the function, integrate the series. And then the substitute. This is an approximate. The value you get is an approximate value of integration. If you have more terms, you have more accurate value. More terms, because here we calculate up to 6 terms. If you calculate up to 8 terms, 9 terms, 10 terms, you get more accurate. The error will be less. The error will be less because this is approximate value, not the exact value. Same here. X cos x cube. X, this is, I think, the final example for this chapter. So here we have x cos x cube. So you need to find the Maclaurin series. You need to start from Maclaurin series of cos x. You need to start from Maclaurin series of cos x. So Maclaurin series of cos x is equal to okay, Maclaurin series for cos x is equal to 1 minus x squared. So x squared over 2 factorial plus x to the power 4 over 4 factorial plus x to the power 6 over 6 factorial minus, should be minus, plus x to the power 7 over 7 factorial, x to the power 8. Plus x to the power 8 over 8 factorial minus x to the power 10 over 10 factorial. Now we have 6 terms, I think. 2, 3, 4, 5, 6. Now we have 6 terms. If they didn't mention to you how many terms, 4 terms is enough. But here we have to follow the instruction 6 terms. So this is why I write until 6 terms. This is the cos x. Now we need to find cos cube x, cos x cube. Cos x cube. So you need to replace each x by x cube. Cos x cube and then multiply by x. So you have 1 minus x squared over 2 factorial, so become x to the power 6 over 2 factorial. X to the power 6 over 2 factorial. We replace x by x cubed to the power 2, then you have x to the power 6. Now here x to the power 12 plus x to the power 12 over 3 factorial minus x. You need to replace x by x cubed, so you have x to the power 18 over 4. Sorry, this one. This is 1 4 factorial, this one 6 factorial. This one 4 factorial, this one 6 factorial. Okay, plus x. Replace x to the power 8 by x cubed to the power 8, which means x to the power 24. Minus x over 10 factorial, you have x to the power 10, x cubed to the power 10, x to the power 30. X to the power 30. So this is the Maclaurin series for cos x cubed. You need to multiply by x and then integrate. You need to multiply by x. So x cos x cubed. We need to write. Maybe we can write on the next page. So I need to multiply by x. So you have x minus x to the power 7 over 2 factorial plus x to the power 13 over 4 factorial we need to integrate from 0 to 1. X 13 over 4 factorial. Here also multiply by x, so minus x to the power 19 over 6 factorial plus multiplied by x, so x 25 over 8 factorial minus x 31 over 10 factorial dx. 10 factorial dx, and then you need to calculate the integration from 0 to 1. You need to evaluate the integration from 0 to 1. The integration of x is equal to x squared divided by 2. The integration of x to the power 7 over 2 factorial is x to the power 8, x to the power 8 over 8 multiplied by 2 factorial, and x 13 is x 14 over 14 multiplied by 4 factorial and so on. You need to evaluate the integration for all terms. X 14 over 4 factorial multiplied by 14, and then you need to substitute from 0 to 1. From 0 to 1. From 0 to 1. So you need to substitute x equal to 1, x equal to 0, or the term will be cancelled. So just x equal to 1 up to 6 terms, you need to find the results. You need to find the results. So just simply you need to use you need to find the Maclaurin series for x cos x cube. You need to find Maclaurin series for x cos x cube. So this, we know the Maclaurin series for cos x. Use it to find the Maclaurin series for cos x cube, and then multiplied by x. After you multiply by x, integrate the Maclaurin series from 0 to 1. Maclaurin series is easy to integrate because this is a power functions. Just add 1 to the power and divide by the new power. 1 plus 1 is 2. Thus the integration of x is x squared over 2. Here 7 plus 1 is 8. So x over 8 divided by 8 multiplied by 2 factorials. All the terms from 0 to 1. Here I use 6 terms because the instruction of the question asked me to 6 terms. If there is no instruction, up to 4 terms is okay. Because the difference only is how much accurate your result. That's all. But in all cases, it's an approximate solution. It's not the exact value of the integration. If you have any question, write on the chat, because by this one we end chapter 5.